What are we asking questions on?
If you have any questions from last experiment. I'm asking if you have any questions from last experiment 2 or from experiment 3 before we start going over the actual experiment for today. Okay. And if you don't have questions, we're just going to go over the factors. Could you tell me how concentration of the reactant could affect the rate of the reaction? Or
yes, the more concentration, the more you add, the more opportunities there are for them to be to collide into each other at the point of activation where they actually change over. So the more you have, the more opportunities you get.
very good explanation. So when a chemical reaction takes place, you have your reactants. Okay, you have your reactants at the energy level, and then you go to the product at a new energy level. So if you have your reactants here and products, and let's say if only 50% of the reactant would go through the transition state to make to the product, the more reactant you have, that then the 50% of 100 is 50, but 50% of 10 is 5, like simple explanation. So the greater number or higher concentration, it can give you more chance for collision, as you said. There are two factors. One is number of collision, and the second factor is the effective collision. So effective collision meaning that they must have enough energy to get to or to pass the requirement, which is called the activation energy. So this is the the amount of the energy. If you look at the energy diagram, this is the activation energy. So if the collision it's not doesn't have enough energy, is not going to go to product. If there is no collision, then there will be no product at all. So very good. The amount of the number of collision, it's a major factor. The higher the concentration, it will give us greater chance to get to the product site. Okay, next factor is the temperature. How does temperature affect the rate of the reaction?
The increase in temperature speeds up.
And could you explain how the increase in temperature increases the rate of the reaction? If you look at this energy diagram, you see the whiteboard, right? With the energy diagram, how can we explain based on the energy diagram?
Well, wouldn't the more heat you put into it, the higher it goes, the more energy you're putting in? So that way you're pushing it to do more because there's more energy available.
Mm-hmm. And Robert, what do you think? Robert and Sabrina, what do you think? I didn't say the explanation is incorrect or correct. I'm just asking. The more energy added, it will
Well, temperature will act as a catalyst, would it not? If it increases.
Okay.
If it decreases, it wouldn't exactly speed up that rate.
What is for sure known that in a chemical reaction, activation energy plays a major role in the speed of the reaction. Activation energy is the difference between energy of the reactant and the transition state. So basically, it counts as an obstacle. So when you increase the temperature, that is correct also, Sabrina. When you increase the temperature, instead of you reacting starting from the blue level, they are going to start from this green level. Let's say we just increase the temperature this much, okay? You just increase the temperature. This is a change in temperature that you have, increase the temperature. So if you have the change in temperature of like a few degrees, what's going to happen here, you are going to get new activation energy, and the new activation energy is lower than the original activation energy for this reaction. So by increasing the temperature, you are going to increase the kinetic energy or the average energy of the reactant. So if this is the energy line, the higher the level of the reactant. So our reactant now are in the higher energy level. If they have higher energy level, is going to affect in a couple ways. I'm just trying to help you understand why change in temperature is going to affect, because it's not just bringing this level up, so it's going to decrease the activation energy. The other factor, we said number of collisions, right? If you have number of collisions, if you have same number of molecules in a container and low energy, they are moving slow, right? Even in liquid phase, they are moving, but they are moving slow. If you have the same number of molecules, so let's say concentration stays the same, and you increase the temperature, your molecules is going to start moving faster. And the faster the molecules are going to move, they are going to collide more often. And if they collide more often, now you're increasing number of collisions, that it kind of translates to increasing concentration, right? And we already know that increasing concentration is going to increase the rate of the reaction. So it's going to affect it. Increase in change in temperature, the energy of the molecules, exactly. It also increases the number of collision. And as a result, you would have higher rate, because the greater number of collision is going to end up with greater number of effective collision and higher concentration of the product over short time. So you get changing concentration of the product and the reactant over the time, higher value, and that translates to rate of the reaction. So we see the change in rate of the reaction. So those are two factors. One is concentration, one is temperature. What is the next factor that affects the rate of the reaction? Yes, Nia?
The catalyst, because it lowers the activation energy, so more molecules.
Catalyst also, very good. Yes, we have few responses. Catalyst is another factor. And what's going to happen with the catalyst? Catalyst would change the transition state, because when you use catalyst, let's say you originally had the blue line for the reactant or the energy diagram. Now, by adding catalyst, you are going to lower the transition state. You basically lower the activation energy, and the lower the activation energy, the faster the reaction. So at the end, it really matters, like, what is the activation energy? So when you're talking about like a steep reaction, shallow energy diagram, or change in concentration or affecting change in temperature, remember last experiment, you studied the effect of the temperature basically, and that affected the EA value, or the activation energy. So increasing temperature of the reactant is going to give you the green line, and that is lower activation energy. Adding catalyst would lower the level, the energy at the transition state. That also translates to lower activation energy. And any factor that can lower the activation energy is going to give more product. It's like, in a way, when students are taking, let's say 100 people are taking an entrance exam, let's say they're taking a PE for professional engineers, or they take a PCAT or MCAT, there are two factors. Either this 100 students, they have been taking classes, spend time, they are really ready, so to take the test, or the test is easy. In either case, more people are going to pass the test, but with like a 70% minimum, if that is the case, like for PEs. And then for if that's not the case, if the test takers are not prepared and the test is hard, then a smaller number of the people is going to pass the test. And is there any other factor?
Well, wouldn't inhibitors be a factor in these? Anything that inhibits?
Yes, inhibitor is the opposite to catalyst. So inhibitors, it's going to inhibit, basically is going to increase the activation energy. And since it's going to increase the activation energy, basically is going to make it harder for the reaction to happen.
So that would make temperature both a catalyst and an inhibitor, correct?
Catalysts and inhibitors, they are,
well,
yes.
Well, temperature would be both, right?
Uh-huh. Yes. And the last one, state of the reactant. State of the reactant. Any state or condition that your reactants are, that gives better chance for collision, more surface area, is going to increase the rate of the reaction. A reaction that happens in an aqueous solution form is going to be much faster than the reaction that is happening from a solid phase. A solid phase, it's kind of the molecules inside, they are protected. So only the surface molecules from the surface is going to react. But if it's powdered, then every molecule or every atom of the element is able to interact with the other reactant or the reagent to go to the product. Okay, so these are some of the factors that is going to affect the rate of the reaction. We learned this in lecture, but in the lab, we are trying to look at different examples. So basically, it's not teaching something new, but it's making your learning more deepened. So this way, you would basically understand more about the reactions, and then it makes more sense. You might, and hopefully you would remember for longer time, because you actually examine like different situation and how it's going to affect the rate of the reaction. Questions for me? Go back to going to stop the whiteboard and bring the lab manual. Do you have any questions for me? Especially if you have looked at the video, if you have any questions, let me know so we can. Yes.
The measurements will be on in the chat, right?
Some measurements are qualitative analysis, so you have to watch the video. Others are like the number, let's say, if you put powder or granular zinc versus chunk of zinc in the acid, it's very hard to put that in chat. So the faster that it reacts is going to probably give like a color change faster, or more bubbles or faster bubbles. So you watch the video, you also look at the chat area sometimes for the numbers. If it's quantitative analysis, I put those numbers in the chat area, because when let's say I say 2 or 3, and then you know what you hear. So, and if it's 2 or 3, is going to make a big difference in the result. So in that case, I make sure to type it. But if it's something that you would see, then you would, yes.
Okay, thank you, Professor. You answered my question.
Perfect.
Thank you.
So if it's quantitative, it would be in the chat. If it's qualitative, it would be on the video. So I don't write, explanation, because it's something that you would watch to see it. And some of these answers, they come from qualitative. Most of it's come from qualitative analysis. So it's a very easy, straightforward experiment. You better watch it than me talking about. But I'm just going to look at the part A1. Look at the reaction A. In the reaction A, this reaction, what do you expect? Fast or slow? This precipitation.
Can you put it up? Sorry, I can't see
It
it.
be faster, A or B?
Hold on.
And what is the difference between A and B? Which one is going to be faster, A or B?
It would definitely be A, because it's in its AQ form.
Okay, very good. So we also have some responses in the chat, which is good. That for the A, you start with the aqueous form, and that explains the state of the reaction, a state of the reactant. If it's in the aqueous form, they can move faster, they can move around freely, and the collision is more, greater chance for collision. So you can get to conclusion that A is going to be faster, because for B, the compound is going to be solid. Your reactant is solid. So reacting of a solid is going to take longer, because only the surface molecules are going to react, and then the inner molecule or molecules in the inner layer, they have to wait for the surface to go away, and before they can be exposed to the reagent.
Are these your elementary steps?
Okay, I want to make sure that I understand the questions first. What do you mean by the elementary steps?
Never mind, I'm confused. Never mind, you haven't got there yet.
Okay. Okay, any questions from any part of the reactions or the experiment? Yeah, it's very straightforward, but it is very useful. We used to skip this one and then decided no, it does help the students. When I did teach both lecture and the lab, students, they found this very useful for like visualization and understanding. So I did bring it back to the schedule. But there is no, complications or no complex ideas here. If you don't have any questions, I'm just going to stop here, really, and I have you watch the video to collect your observation, to record your observation, and then finish the data sheet. Next week is the spring break, so we don't have lab next week. Our next lab is going to be Tuesday, March 9th. The papers or the assignments for the next one, the pre-lab for experiment 4 and the data sheet for experiment 3 is going to be due on March 9th before 11 a.m. I hope that you enjoy your spring break, and I also hope that I can grade some papers. I have so many papers that they are just waiting for me to be graded. So I would use some time to grade those papers. Any questions for me? No questions? Okay. Your attendance. Megan? Thank you. Megan? Is Megan absent? Okay.
I'm here.
Tiziana? You're here? Okay. Thank you. Tiziana?
Here, Professor.
Yes. Thank you. Juan?
Here.
Thank you. Simon?
Here.
Crystal? Okay, not Crystal. Okay, it's not. Robert? Thank you. Natalie? Aline? Janelle?
Here.
Thank you. Caitlin? Isabella?
Here.
Isabella, I have absent for your last class. Were you absent or you didn't respond?
Yes, my internet wasn't working, so I wasn't able to log on.
Okay. Nia? Nia?
Here.
Thank you. Andre? Thank you. Camilla?
Here.
Perfect. Kaylin?
Here.
Thank you. Jonica? Thank you. And Neftali, I think she's withdrawn. Alex? Alex? Okay. Crystal? Thank you. Alana?
Here.
Perfect. Naveed? Thank you. Daniela? Luke?
Here.
Let's see. Naya? Naya? Thank you. Sabrina? And Euben? Perfect. Okay. If you have questions at this point, you may stay to ask your questions. If you don't have questions, thank you and have a nice day and enjoy your spring break. Thank you. We'll see you in 2 weeks from today. Yes, Juan, your question.
Hello,
You
Professor.
can use.
Can you hear me?
Yes.
Oh, okay. Give me 1 second.
Sure.
Okay, Professor. So what happened is that I didn't see the assignments that were due today on the assignment folder, and I don't know if it's because something's wrong with my D2 or anything, because I did buy
No,
the access
no.
code online.
You did buy the access code?
Mm-hmm.
And you did submit it?
No, I think I forgot to do that.
That's why. You forgot to submit that, and that would have give you trouble last week as well, because experiment 2 pre-lab also was conditional.
No, that actually I did see that one on the assignment folder. I didn't have issue with that one. I just had issue this week, but I
Okay.
still got it. I sent you an email yesterday, and I also sent you one this morning with the assignments because
I cannot grade. I probably replied to you and said that this needs to be submitted to the assignment folder. So I'm glad that you are here and you're telling me. And as soon as I check to make sure that you are set, first of all, you have to purchase the ebook and you need to submit into the assignment folder that is called. The only thing that I can make sure that assignment folder should be open at this point for you to submit it. And if you have not, okay, I'm going to open it now. So you can submit, then you should be able to see it.
okay.
It was open until the 16th, but I'm going to make it open. Stay open until the 28th. So this way you can submit before it's too late. And then you would see the assignment folder. And when you see the assignment folder, if the assignment folder is closed, you email me, I open it for you
Okay.
to submit as a late submission.
Okay.
I won't be able to, unfortunately, I will not be able to grade in the as an email attachment. I do not have the rubric.
Okay, that's fine.
Okay.
Okay, no problem.
Sure.
Thank you, Professor.
You're welcome.
You have a
Thank
nice
you.
day.
Thank you so much. Okay. Andre, Crystal, Naya, you have any questions for me?
I do, Professor.
Yes.
First, I got a question regarding my submission on experiment 1, post lab 4.
Okay. Post lab 4, I have not graded yet. Let me see. Is it submitted or is not submitted?
No, it's submitted. You graded it.
Post lab, I just graded the pre lab today. Or was that the post lab?
Hold on 1 second. Give me 1 second. Let me double check. Because I'm pretty sure. I hate it when it does that. I'm pretty
No,
sure.
I graded the pre lab for week 4, but not
No,
the post lab.
yes. Okay. So it's okay. Hold on. Let me get my pre lab up then. Pre lab. Pre-lab for what was it again? Sorry. Pre-lab week 1 experiment 4 pre-lab, and that was due. Week 1 pre-lab questions.
Okay, your answers were very general. Okay.
So it was hard. I want to go over it because. Okay, so.
But if you look at the question, okay, it says that possibly present, confirmed present, absent, or no conclusion.
Oh, I get it. So I get it. So my issue here. Okay.
So there is really no, it's you're for question 1A, you could still have, what is it? You could still have the.
Because I look at it generally, so it's hard for me because I know what you're saying and I get it and I understand it, right? I get what you're saying there, but for me, when I look at that, I don't see a conclusion because, and I know it says possibly, and I get how you, because it, I guess it is possible, but you would need further experiments. That's why I kind of did that, because
that's what it says. Just say, is it possible that you can But if you say no conclusion, that means there was no evidence for you to conclude anything. But here it's saying that you do have a precipitate, and the precipitate is not a red color. With KSCN, it should be like a red color to say there is iron. But if it's different color, you could still have nickel or manganese, and then you could still have chromium and zinc.
Okay. Because honestly, I applied the same. You can see it's the same question as the other one I got wrong with the no conclusion. It doesn't tell us anything. There's no conclusions from it, right?
Okay, NaOH was added a blue-green solution after stirring, no precipitate form. This one, there is a conclusion. Let's instead of that, let's look at the page. I had it open because I was grading. Page, I think it was the 22 flow chart. Let's look at the flow chart. For group 3. Okay. I mean, you are doing so well in the course, and you have very good understanding that I'm not worried about your final grade, but this one, I just want to make sure.
Well, I want to, because in case there's a question in the final.
Okay, look, yes, exactly. That's why I'm glad that you're staying and you're asking these questions. Look at this flow chart. Okay, you have all 5 of them. You're adding sodium hydroxide. Okay,
so
and
you see,
it says there's no precipitate forming.
Give me 1 second before you go, because the way I looked at pre-lab 1 is the way I look at every experiment like this when you asking that question, right? I make as if there could be all 5 of them in there, or there could be 0.
Okay. Let me ask you this question first, Andre. Just look at the steps 3A, just the 3A on the chart. You see the chart now, right?
Right.
Okay. Look at the 3A and the chart. What is the next step when you add sodium hydroxide? What's going to happen there?
So the first thing that will happen there is your solids will precipitate out, right?
Okay, which ones are going to precipitate?
Your nickel, your iron, and your
manganese only, right?
Yes, manganese.
And if there is no solid, what does it mean?
I guess you could say at that point it's possible that there would be zinc and chromium in there.
Yes, but you have no iron, no nickel, and no manganese, right?
Because there's nothing's precipitated out.
Okay, perfect. So that's what I was looking for, because if there is no precipitate forms, then it's for sure these 3 are absent, but about the other 2, they are possibly present. We don't know they are present or not. They are possibly present.
Okay. All right, no problems. No problems. I was just wanting to make sure, because the way I look at it, I guess in my brain, it just says to me that I don't like the possibly, possibly doesn't sound super scientific to me, so I don't like it as an answer, but I get it. Okay, that's no problems. That's no problems. And that's
I'm not worried about your final grade. It's just something like, if this individual paper, this unique, this paper, if I see that, yes, you could have conclude something, you could say either like possibly present or definitely absent. Like in this, like 1D, the 3 ions, definitely they were absent, otherwise you would have get precipitate. So you could have put that in there. So it's just one.
Yeah, because the same way I look. Yeah, all the logic is it's so weird, because it says you add KSN and then you're expecting an outcome, right? So the way I
And
look at
red
that
color,
question,
bloody
Mhm.
red color, right? The outcome that we are looking there is a bloody red color
yes, right?
for
And
iron.
then, right. So when I did that one, I guess it's just my brain saying, hey, you were checking for iron, but you didn't find any. I didn't think that they were checking for all, because I only apply the KSCN to the iron one. So that was just my thought. It's okay. I get where I went wrong.
No, it's okay. But we are here to make sure that if you get exact same question, which is
Mhm.
possibly,
Mhm.
you get on the final exam, then at that point you have the answer. So
Right.
I am happy that you're asking. So let's say if you add the KSCN and you don't see red color,
Mhm.
then iron is not there or
But
possibly
nickel
not,
and
right?
manganese will possibly be there. So
Yes.
you just have that would be like a, hey, iron's confirmed not there when we added the KSN, but further experiments need for Ni and manganese. Okay. All right. Thanks, Professor. Thank you very much.
You're welcome. You're welcome. Thank you. Okay. See if we have other questions. Naya and Crystal, do you have any questions?
Yes.
Yes.
It's also so experiment 2 data sheet. I don't know if I did the graphing right. It's just the graph. That's it. Yeah.
Did you submit already?
Yes.
Okay. If it's wrong, when I grade it, I will make comments, proper comments.